Hello, this is Math 2231 coming to you from the College of DuPage for the summer of 2020, and this lecture is entitled Calculating Indefinite Integrals by Substitution. By way of introduction, there's a strong analogy that you had from your algebra studies. Once upon a time, you were asked to solve an equation that looks like this: 3x plus 5 whole squared minus 9 times 3x plus 5 plus 20 equal to 0. Now, you could have expanded this, collected like terms, and then solved it using the quadratic formula or factoring or something like that. But this was much more easily handled by doing a substitution. And the substitution coming to mind is u equal 3x plus 5. So if everywhere I have 3x plus 5 I put a u, I'm going to have u squared minus 9 times u plus 20 equal to 0. And that factors into u minus 5 and u minus 4 equal to 0. That means u is 4 and u is 5, our solutions. But since u was 3x plus 5, that means that 3x plus 5 is equal to 5 is a solution, and that nets you x to be 0. And that means that 3x plus 5 equal 4 was a solution, and that nets you having x is equal to minus 1/3. This is what we're going to be doing, but we're going to be doing it in a calculus integral context. So consider the following integral, which looks somewhat formidable. But what we're going to do is we're going to simplify this with the u substitution. We're going to say let u equal 6x cubed plus 5. And we have to, if we're integrating, we have to have a du. And so du is going to be the differential. That's going to be the derivative of this times dx. So this is going to be 18x squared dx. And in my class, students often like to solve for the dx. And so dx would be equal to du over 18x squared. So if I substitute this for dx, what will happen is that the 18x squared will cancel. Magic happens. It is gone. And here I have u raised to the 1/4 power. So you see this integral becomes the integral of u to the 1/4 du. And you know that this is u to the 5/4 divided by 5/4, which is the same thing as multiplying by 4/5, plus c, and then I reverse my substitution, putting what u really was. And this is the answer to the original problem. This is often called the u substitution. You change the problem that starts out being an x to be an integral in u, and then you reverse your substitution at the end of the problem. Here are 4 problems for you to give a go. Let's see how you do. Let's see how you did. In this one, this will work. U is equal to w minus the natural logarithm of w. That means that du is equal to 1 minus 1 over w, dw. That means that dw is equal to du over 1 minus 1 over w. So you see, if we substitute that in for dw, this in the numerator will cancel with that in the denominator, and I'm just left with cosine of u. And the indefinite integral of cosine of u du is sine of u plus c, and then I reverse my substitution. This problem, it makes sense to consider u is equal to 4y squared minus 1. That means that du is equal to 8y minus 1 dy, or dy is equal to du over 8y minus 1. And you see, when I substitute that for dy, this 8y minus 1 will cancel. Magic happens, and the 3 can be pulled through the integral, and I'm left with 3, the integral of e to the u du, and it's this, and I reverse my substitution, and that's the answer to the problem. Here's another problem for us to do. Let's try this. U is equal to 3 minus 10 x cubed. That means that du is minus 30 x squared dx, and that means that dx is equal to du over minus 30 x squared. If I substitute this in for dx, you see the x squared cancels, magic happens, and I have u to the fourth. So when I make that u substitution, this is what I get. And when I integrate u to the fourth, pull the minus 130 through, I have u to the fifth over 5 plus c. And then I reverse the substitution because my answer has to have x's in it. One more problem, this one. Here I let u equal 1 minus 4x squared. That means that du is equal to minus 8x dx. That means that dx is equal to du over minus 8x. Notice that the x's will cancel when I substitute that in. That means magic happens, and I will pull the minus 1 over 8 through the integral, and I will have the integral of u to the minus 1/2 du. I add 1 to the exponent, divide by the new exponent, and do the calculation. I get minus 1/4 u to the 1/2 plus c, and I put what u is in terms of x, and I am finished with the problem. Here's 3 more problems for you to do. You know what to do, and I will see you in 32